Honey?
What?
What happened to my shoes?
What do you mean?
Well, this one says the square root of answer, and this one says answer to the half.
Vincent, you should know better. They're the same thing.
Oh. Alright, so if you didn't get the joke earlier, that's okay. The joke was that the square root of answer, which happens to be the logo for Vans, is equal to ans to a half. This turns out to be true. Let's talk about why. In general, if I have a number x raised to a power that has a fraction with 1 as the numerator and n as the denominator, that is the same as taking the nth root of this number x. So, for example, square root of x, we know we're taking the second root, so the square root of x is x to the half. The fifth root of x is x to the fifth. And so, the square root of ants, which is the logo for the company Vans, is equal to ans to the half. We call this the radical form, and this the exponent form. Sometimes you'll even see a power inside the radical like this. Well, this can be written this way, with the power as the numerator instead of a 1. It also works this way when the power is outside of the radical. So, if you were given this question, write in exponential form the fourth root of x cubed, you can simply write it as x to the 3 over 4. Or, if you were given this question, the fourth root of x all cubed, you'd get the same answer, x to the 3 over 4. In general, the rule is the mth root of x to the n is equal to the mth root of x all to the power of n. Both of these are equal to x to the n over m. Additionally, since we are working with exponents now, it is very important to remember some of the power laws, which are as follows. With all this in mind, let's now turn to the whiteboard for some more complicated examples. Okay, so this first example is telling us to write this radical as a power. To do that, we're going to first turn everything into exponent form and then apply all our power laws, okay? So, I see that this is the most complicated thing in the question, so I'm going to start with that. So what I'm going to do is write this using all the rules we just talked about. So inside the bracket, we're going to have x to the 2 over 7 using the new definitions we talked about. And this is all raised to the power of 3. Okay, so what happens next is we now have a power raised to another power, and the last rule I talked about means that tells us that we're multiplying the two. So we're going to be left with x to the 2 over 7 times 3. And equivalently, this means our answer is x to the 6 over 7, because 2 over 7 times 3 is going to get us 6 over 7. And that's our final answer. So this example is asking us to evaluate this exponent without a calculator. And turns out there's actually 2 different ways we can approach this question, and I'm going to talk about them both. So the first way is to write this as the third root of 27 squared using our definitions. Or we can do this by doing the third root of 27 and then square all of that. Okay? If I were to do it this way, well, I would see that I'd have to evaluate this 27 squared. And if I did all that work by hand, I would probably do it something like this. And I actually have this in my notes, what the answer is. Turns out it's 729, which is a pretty big number. And so I'm taking the third root of 729. And if I were to figure that out, I'd probably use a factor tree. And at the end of all that, I would find that the answer is 9. And so some problems I see is I get a big number, and I also have to do a factor tree. And that's a lot of work. That's a lot of work. Let's see how we can do this one. Well, it turns out 27 is actually a perfect cube, and I can just simply write this evaluated. So the third root of 27 turns out to be 3. And I'm squaring all of that, and that turns out to be 9. So both these answers are the same, but this way was easier. In general, if you're able to make the number smaller, notice how here, if we were going to square a big number, we'd get a bigger number. Try not to do this. Don't do if you can. As opposed to making it smaller. So making it smaller. The strategy you want to really be focusing on for questions like this is to make the number smaller first and then making it bigger, rather than making it bigger and then smaller. Okay, here's another example just like the one we did before. And I'm actually going to be approaching this with the strategy where we made it smaller first. And so I'm going to write this. I see that I'm going to be taking a square root because the denominator is a 2. And then I'm going to be cubing because the numerator is a 3. So what I'm going to write this as is the square root of 16, because that's where the 2 is coming into play. And then I'm going to be cubing that. Okay, so I'm going to be making it smaller first and then making it bigger. So when I apply the square root of 16, which happens to be 4, I'm going to be cubing that. And so this gets me a much easier question to do. This turns out to be 64. Imagine if I cubed 16 first and then had to find the square root of that. That's a lot more work. So try not to do that if you can. Okay, here's another question where we're being asked to evaluate without a calculator. And well, I see a decimal in the exponent, and it's not a fraction anymore. But I do see a fraction here, so maybe I'm gonna have to work with fractions anyways. Well, what I see is 0.5. Well, this number is equal to a half. And so I can just write this as 4 over 9 to the power of a half. And when this happens, I know that a power of a half is going to get me a square root. So this ends up being the square root of 4 over 9. And when we have a fraction and a radical all around it, you can split it up. So I can take the square root of 4 and the square root of 9, and that ends up as 2 over 3. So this problem, we converted to something we were familiar with using a little trick, turning the decimal into a fraction. So we're turning decimal into fraction. And this just makes the whole problem more accessible. Okay, in this final problem, I'm looking at 12 over 27, all to the power of 1/5. And so I'm going to be using the same strategy I did in the previous example, where I turned this number into its fraction form. 1.5 is written as 1.5. But that doesn't, now there's an extra number, this 1, and I was used to having a number on the top, the numerator, over the denominator. So to do that, I'm just going to turn it into an improper fraction. And what that gets me is the number 3/2. And so I can rewrite this 12/27 as, or that whole question, sorry, as 12/27 to the 3/2. Looking at this, I really want to make the number smaller first. And so I'd love to take the square root because of the 2 of these numbers. But 27 and 12 aren't actually perfect squares. So I think I might have to do something else first. Looking at it a little bit, I do see that I can reduce this fraction a little bit. So let's try doing that first. 12 and 27 have a common factor of 3. So if I take out a 3, I'm left with 4/9 to the 3/2. And that's totally doable. That's a square and that's a square. So I'm going to rewrite this question as taking the square root of 4/9 and then raising that to the 3rd power. And so doing this, I have the square root of 4 on the top. Oops, square root of 4, getting a little bit ahead of myself. The square root of 4 over the square root of 9. And I'm raising all of this to the power of 3. This is going to get me 2/3 to the power of 3. And I've run out a little bit of space, so I'm just going to go here. And so I'm just going to evaluate this now. I'm going to do 2 cubed, which is 8, and 3 cubed, which is 27. And that's my final answer. Okay, in this video, we covered fractional exponents. In the next one, we'll be covering negative exponents and reciprocals. Until then, stay safe and take care. Bye!